Okay, in this video, we're going to work problems using the chain rule. The level of difficulty will be advanced. In the previous video, we did beginner to intermediate level. And so really when it comes to advanced level of difficulty, you're going to have more layers of the chain rule. So I don't think for this problem, we've got more than 2 layers, but in upcoming problems, we'll have like, you know, f of g of h of x, right? So you do the chain rule and then you're doing the chain rule again. So that just gets a more confusing, but still the same concept, still the same theory, chain rule theory as in the beginner video, right? We're still doing the same things that we did in those beginner problems. It's just more complex. Okay, so we want to find h prime of r. So the biggest picture we have is like we need to do the chain rule for this function of r in the numerator, and then also for this function of r in the denominator. But as a whole, like just we've got a fraction here. There's no chain rule for the fraction. Like we start by doing the quotient rule. Okay, so we're going to do the quotient rule. That's the first step is to say, okay, let's do the quotient rule on this fraction here. We haven't said we're doing the chain rule yet. So here we go. So derivative of the top. Now we need to do the chain rule, right? So the derivative of the top. We've got something cubed. Okay, so the derivative of something cubed is 3 times that something squared, right? Times the derivative of that something, 2r. Okay, so that is the derivative of the top. Okay, now times the bottom. Okay, minus the derivative of the bottom. Okay, we've got something to the 5th power. Derivative of something to the fifth power is 5 times that something to the 4th power. Now times the derivative of that something with respect to r. That's just 2. Okay, so derivative of the top times the bottom minus derivative of the bottom times the top. Okay, now all over the bottom squared. 2r plus 1 to the 5th squared is 2r plus 1 to the 10th. So that's your derivative. We just need to simplify this as much as we can. So h prime of r, what can we factor in the numerator? What can we factor out? So we can take out a 2. We can take out an r squared minus 1 squared. We can take out a 2r plus 1 to the 4th. All right. So now let's just write what we have remaining. Okay, so these 2r plus 1 to the 4th cancels, and we're left with 2r plus 1 to the 6th in the denominator. All right, now let's distribute all of this and simplify. So this is 6r squared okay, so what we're left with is okay, and that is your final answer. Okay, so f prime of t is, all right, so chain rule. We've got, what is our biggest picture? We've got e to the something. It doesn't matter what this something is. This could be absolutely anything. What is the derivative of e to the something? It's just e to that something. right? Times derivative with respect to t of that something. If it was just t, then we'd be done. But it's not just t, right? Derivative with respect to t of this is, well, we need to use the product rule here and the chain rule for sine of 2t. So there's one function of t, there's another function of t. So derivative of the first, 1, times the second, okay, plus derivative of the second, okay, chain rule again. So what is our biggest picture here? We know that this is the sine of something. We know the derivative of the sine of something is the cosine of that something times the derivative of that something, okay? So now let's come back and see what were we doing, right? It's confusing. We just did this chain rule. Now we kind of forgot where we were at. We were doing the product rule. We took the derivative of the first, multiply it times the second. We just took the derivative of the second. Now just multiply it times the first. Okay, and so that's your derivative. Just clean it up. And that's your answer. Okay, so dy dx is, we've got the derivative, or we've got what is the derivative of cosine of something? That's just minus sine of that something. Okay, now times the derivative of that something with respect to x. So the quotient rule, derivative of the top, okay, 0 minus, so the derivative of minus e to the 2x with respect to x. Chain rule again. So derivative of minus e to the something is just minus e to the something times the derivative of that something, okay? So that is the derivative of the top, okay, times the bottom, just as the bottom is, okay, minus the derivative of the bottom, okay, derivative of 1 is 0, derivative of e to the 2x, so e to the something, derivative of e to the something is just e to the something times the derivative of that something, okay, so derivative of the top times the bottom minus the derivative of the bottom times the top. All over the bottom squared. All right, so that's your derivative, but now you need to do a bunch of algebra to clean it up. Let's work on this separately. Okay, so dy dx is equal to okay, so our final answer, let's bring this minus sign, let's bring all this to the front, combine it with this minus sign here, so we get okay, so the biggest picture we have, like, is the cotangent. Well, for the chain rule, it would be helpful to rewrite this. So this is really equal to what? This is equal to the cotangent of sine of theta squared, right? That's what this means. So we start off by saying we've got something squared. So dy dx is equal to, okay, the derivative of something squared is just 2 times that something, and that's it, to the 1 power, okay? So now times the derivative of that something. So now, so derivative of cotangent of sine theta. Well, what is the biggest picture there is cotangent of something. What is the derivative of, that's the base derivative. What is the derivative of the cotangent of something? So I don't know this off the top of my head, but you can look this up. Derivative of cotangent of x is equal to, with respect to x, is minus cosecant squared of x. So the derivative of cotangent of something is minus cosecant squared of that something. But then times, again, times the derivative of that something, times the derivative of sine of theta, cosine of theta. Okay? So that's it. That's your derivative. So let's just clean it up. So we've got 2 cosine theta. Let's bring this cosine theta to the front. And then this minus sign we can bring to the front. Cotangent theta, cosecant squared of, or cotangent sine of theta, cosecant squared of sine of theta. Okay, so we've got, again, this is a little confusing, this sine squared, because it's tempting to say that we're starting off with a sine of something, but this is equivalent to, for the sake of the chain rule, let's rewrite this. Right, that's what this means. Okay, so we've got something squared. That's what we're starting off with. That's our biggest base derivative, biggest picture. So derivative of something squared is 2 times that something, and then that's it, because there's no power with something squared. So 2 sine of e, right? And then so times the derivative of that something. Okay, so now now you can see we've got a chain rule embedded within a chain rule embedded within a chain rule. That's why these are advanced. Like, so now we need to take the derivative of this. So maybe we want to put a bigger bracket here. Okay, so we've got the derivative of e to the sine squared of t. That's e to the something. Derivative of e to the something is just e to that something times the derivative of that something. Here's another chain rule, right? The derivative of sine squared of t, that's something squared. Derivative of something squared is 2 times that something. 2 times that something times the derivative of that something. Derivative of sine of t is cosine of t. You see? Okay, so let's just clean this up. So I'm going to bring these sines of t's and cosines of t's to the front. So 4 I mean, you could argue that maybe it's simpler to put the sine, this sine of e to sine squared of t first, and then, so, But I think that looks pretty clean to me. And that's your answer. Okay, so this one, yeah, like this is just going to be, again, it's the same thing we've been doing, but it's going to be tricky because we need to keep track of all of these constants, right? Whenever we're taking the derivative, everything that's not x is going to be a constant. So, okay, so g prime of x is equal to, all right, try not to overthink this. This is the exact same thing we've been doing. What do we have to start? We've got something to the p power, right? Like this is a little different because we haven't been raised, like we've been raising something, like the p is a constant. So dx of x to the p, I mean, you know this, is px to the p minus 1, right? So let's just do that. Like we've got something to the p power. What is the derivative of something to the p power? That's just p times that something to the p minus 1, right? But now we need to take the derivative of that something. Okay, so what is the derivative of 2r a to the rx with respect to x? Well, we could do that on the side here. So dx of two r a to the rx is equal to, so this r, there's two r's are constant, so this can be rewritten as now we've got a to the rx. This is an exponential. This is not x to a constant. This is a constant with an x and an exponent. And we've got the chain rule mixed in. So you have to start with what you know here. Okay, so what do we know about exponentials, right? We have the derivative of a to the something. That's an exponential. That's like saying the derivative of 2 to the x. What do we know about the derivative of 2 to the x? So like if we've got dx of 2 to the x, what is that derivative? That's 2 to the x natural log of 2, right? Because if this was e to the x, natural log of e is 1. But it's a little trickier because we have a to the rx, so we have to use the chain rule, right? So this is 2r. Now derivative of a is like the 2. A is just a constant. Derivative of a to the something is a to that something natural log of a. But then times the derivative of that something, right? We could have said times the derivative of x with respect to x here. That would have been 1. But derivative of rx with respect to x is r. So simplifying this, we've got 2r squared natural log of a to the rx. Okay, so coming back here, we're multiplying times the derivative of this. So we've got the derivative of this with respect to x is 2r squared natural log of a to the rx. Okay, now plus the derivative of n with respect to x, that's 0. There is no x in here. Okay, so that's your derivative. But just, we want to clean this up, right? So g prime of x is equal to, so we could just say 2p r squared natural log of a to the rx, and then 2r a to the rx plus n to the p minus 1. And that's your answer. Okay, so what is our the biggest picture-based derivative. We've got the cosine of something. The derivative of the cosine of something is minus sine of that something. Okay, times the derivative of that something. This is that something, right? We had this was the cosine of something. So now we need to take the derivative of all of this, including with that square root. Okay, so what do we know about a square root? The derivative of square root of x is 1 over 2 root x. So the derivative of the square root of something is 1 over 2. So 1 over 2 root of that something. Okay, times the derivative of that something again. Okay, so that was this, everything inside of the root. All right, the derivative, so there we've got the sine of something. The derivative of the sine of something is cosine times that something. Okay, now times the derivative of that something. What do we know about the derivative of the tangent of x? That's secant squared of x. So the derivative of the tangent of something is just secant squared of that something. Okay, now again, they're really testing you here. Times the derivative of that something. The derivative of pi of x, pi times x with respect to x, is pi. Okay, and that's your derivative. So I don't know how you can clean this up. Let's bring the pi out front. So we've got minus pi, because you have a minus out here. And then I guess, so cosine tangent pi of x. Okay, and then secant squared pi x. And then now let's put this sine of the square root of sine tangent pi x. Okay, and now in the denominator you've got 2 root sine tangent pi x. All right, and that's your answer.